Okay, now we're going to have more questions about the factor theorem, and then we're going to have more equation applying, the remainder theorem. Okay, so we're up to question 6. Okay, before we do question 6, we are going to state the factor theorem. All right. This theorem says this. If P of A equals 0, comma, then x minus A is a factor of P of x. Okay, so that is extremely important. But this works also in the other direction. Okay, so the converse is also true. Okay, so we can also say, all depending on the question, you're going to be using, the factor theorem in this way or in the other way. Okay, so the reverse of this is also true. So we say this: if x minus A is a factor of P of x, comma, then P at A is equal to 0. Okay, so it can be used in both ways. Okay, it's something that you're going to have to remember all the time. Okay, especially when doing exercises, you're going to have to remember these two statements. Okay, and then we're going to see how we're going to apply this for some of the questions that we have next. Okay, so I'm going to leave this here, and then we're going to do question 6. Okay, question 6. All right, in question 6 we have the coefficients of A and B are such that the polynomial x to the power of 4 plus axb plus x plus b is divisible by x minus 1 and x minus 2. And then they say that you're going to find the values of A and B. Okay, things that we need to observe. Okay, first of all, the polynomial is equal to x to the power of 4 and then plus ax plus b. Right, again, so this is not a totally numerical polynomial. Okay, but in here we have A and B. Okay, so we have A and B. And at the end they said that you're going to find the values of A and B. Now, I want you to pay attention to this. From the moment that you see two pronumeral, okay, two unknown pronumeral, and they want you to find them, then you know that you're going to be finding them by being somehow a simultaneous equation. Okay, so keep that in mind. If you're going to find the answer for A and B, somehow you're going to have to solve a simultaneous equation. All right? Okay. Now, another important thing from that question. I said to you before that from the moment that you see the statement saying that, the polynomial is divisible by x minus 1 and x minus 2, in this case, you know that x minus 2 is a factor, and so is x minus 2. Okay, so we are going to use that in this question. Okay, now it's coming a little bit of noise from outside. Hopefully it won't distract you as it distracted me. Okay, so x minus 1 is a factor because this polynomial is divisible by it. So we're going to say solution. All right. X minus 1 is a factor. And then from here, okay, from the factor theorem, they say that if x minus a is a factor, then we can say that p at a is equal to 0. So following this true statement, then we can say, therefore, p at 1 is equal to 0. Okay, that will give me the first equation that I need. And then x minus 2 is another factor. So we're going to say also, comma, x minus 2 is a factor. So therefore, we're going to say that p up 2 now is also equal to 0. That will give me the second equation that we need, for the simultaneous equation. All right. Now, what we're going to do, we're going to substitute this in here, and then we're going to substitute this in there. Okay. So then we're going to say, then we have this. Okay, so we're going to have 1 to the power 4, which is 1, plus a multiplied by 1, so it's going to be plus a, and then plus b is equal to 0. And this is my equation 1. And then similarly, I'm going to substitute 2 in here, so 2 to the power 4 is 16. And then we're going to have plus 2a plus b is also equal to 0. That is my second equation. Can you see that? Okay, so this a and b simultaneous equation is coming from the fact that in here you have a and b in your polynomial. All right, and then we are going to simplify this a little bit more. Okay, so we're going to say, or we can say that a plus b is equal to negative 1, and 2a plus b is equal to negative 16. So this is my equation 1 and 2. Okay, and then we are going to do equation 2 minus equation 1. Okay, so we're going to go in that direction. Okay, so we're going to say equation 2 minus equation 1, and that will give you, so it's going to be 2a minus a is equal to just a, and then b minus b, they gone, and then minus 16 minus negative 1, so it's going to be negative 15. Okay, so that is the value for a. Okay, and then the answer for b, well, we can substitute b in any of this equation. So I'm going to use this one. So I'm going to say from 1, this way we have that a plus b is equal to negative 1. So therefore, well, b is equal to negative 1 minus a. So b is negative 1 minus, and minus will make a positive, so it's plus 15. So therefore, finally, b is equal to positive 14. Okay, so that is the answer for question 6. Okay, these questions are also, very, very popular in test. I have to say that. Okay, so make sure that you remember your simultaneous equations, and also make sure that you remember, the factor theorem, and sometimes the factor and the remainder theorem together. So yeah, that's why you need to do these questions. You have to do them, and you have to do many, many questions until you get fully familiar with the factor theorem and the remainder theorem. And also you need to know how to do long division, I know this, but yeah, that's the way you have to do it for now, until I show you, the other way on a different video. For now, we're going to keep doing, the long division in the long way. Okay. All right. So that's the answer of question 6. Now we're going to do question 7. Okay, question 7. Okay, question 7 has 2 parts. Okay, let's do the first part. Okay, they say if x minus 1 is a factor of that polynomial, p of x equals x cubed plus ax squared minus 2x minus 4, you're going to find the value of a. Okay, this question is a little bit easier than the one that we just did, because in here, first of all, we have only one unknown, which is a. Okay, only one coefficient is missing, and the other one we have 2. So we got the coefficient of x and the constant. They both were missing, but in here we have only one coefficient missing. Okay, and because x minus 1 is a factor, then it's great. Okay, because we can say this. Okay, so x minus 1 is a factor of p of x. Okay, is a factor of that polynomial. Then p at 1 must be equal to 0. Okay, so that is coming from the factor theorem. And then we're going to substitute this into my polynomial. Okay, so p of x is equal to x cubed plus ax squared minus 2x minus 4. And then I'm going to use this statement. So we're going to say, so we have that 1 cube is simply 1, and then plus a multiplied by 1 squared is simply a, and then minus 2 times 1 is 2, minus 4, and that must be equal to 0. Okay, so this part is that part, and then we have to equate that to 0. That's what we're doing here. Again, then, well, so therefore you can see that a is going to be equal to, this is negative 6. So plus 1 is negative 5, and if you move it to the other side, so it's going to be positive 5. That's it. Okay, so the first part of the question was simple. And then they said that you have to factorize p of x completely. All right. Okay, so my polynomial now is x cubed plus 5x squared minus 2x minus 4. And we need to factorize this completely. Okay, so what we are going to do, because x minus 1 is a factor, then I'm going to divide this polynomial by x minus 1 to find the other factors. Okay, so I'm going to say to find the other factors we do long division. I'm going to continue here. So we're going to say that means that we have to do x cubed plus 5x squared minus 2x minus 4 and divide by x minus 1. Okay. Remember, if you divide this by this, the remainder is going to be 0 because x minus 1 is a factor. Okay, so if x minus 1 is factor, when you do the long division by x minus 1, then the remainder have to be equal to 0. If you get something different, it means that you did something wrong. Alright, let's do it. Okay, so we're going to have x squared, that will give you x cubed, and then minus x squared. And then we take away, these 2 will go, and then in here we're going to have 5 plus 1, so it's 6x squared. The next one down, and that will give you 6x, so that will give you 6x squared minus 6x. I'm doing this quickly because I'm assuming that you know how to do this very, very well. Okay, and then this will cancel that one, and then we're going to have negative 2 plus 6, so it's going to be 4x, and then we bring the next one down, which is negative 4, and then we multiply the divisor by 4, so that will give you 4x, and then minus 4, and then you can see that when you do this, take away that, the answer is 0, and that is what we were expecting. Okay, so therefore my polynomial now can be written like x minus 1 multiplied by the quotient, which is x squared plus 6x plus 4, and the question say factorize completely, and I think that that's all we can do. Okay, so and because this is not, we cannot factor this one with integers. Okay, that's it. So we cannot find two numbers that when you times them together equal 4 and plus them together equal positive 6. So I mean that is what they want. Okay, so you stop in here. Okay, so question 7 is done. Alright, I'm going to do question 8 and 9, and then I'm going to have a break, and then I'm going to continue with the rest of the question. Okay, question 8. Okay, in question 8, it says we have to solve that cubic equation. Okay, so we have to solve 2x cubed minus 3x squared plus 1 equal 0. Okay, the possible factors of the constant are positive 1 and negative 1. Okay, so you can see this is the constant, and the only possible factor of 1 is a negative 1 and positive 1. Okay, so we're going to say let p of x equal to this polynomial equation. Okay, and then we're going to see what happens when we substitute positive. So p at 1 is going to be equal to 2 plus 1 minus 3. Yeah, that's going to be equal to 0. Great news. Great news. All right, and then because p of 1 is equal to 0, then by the factor theorem, so therefore we can say that x minus 1 is a factor of p of x. And then to find the other factors, we are going to divide this polynomial by x minus 1 and see what happens. Okay, you can do this question, I suppose, in many different ways. Okay, so you could find, the other factor, and then try to find the other factor, and then multiply them to each other to create or to form this equation. But I'm just going to follow the same format that we have been doing previously. Okay. But yeah, but if you can do this in a different way, you are more than welcome. Except if in the test say doing the answer in some particular way. Okay. All right. Okay. So let's divide from x minus 1 divide this polynomial. Okay, and you can see straight away that something is missing. Okay, what is missing is the x term. So we do 2x cubed minus 3x squared plus 0x and then plus the constant. Okay, now we are ready. Right. So we're going to have 2x squared to get 2x cubed. And then minus 1 times that, so it's going to be minus 2x squared. Okay, we do subtraction, so that will get rid of that. But in here we're going to have minus 3 plus 2, so it's minus x squared. And then we have plus 0x. Okay, and then we're going to multiply by x, so it's going to be minus x squared. And then we're going to have plus x, and then this will go, and then we're going to have 0 minus x, so it's going to be minus x, and then we bring the next one down, which is plus 1, and in here we're going to put minus 1, that will give you minus x plus 1, and then that is equal to 0. All right. Okay, so therefore our polynomial now can be written as x minus 1 and then 2x squared minus x minus 1. All right, and this can be further factored as, let me see, I think I have factorization ready here, so we don't have to waste too much time. Good. So this is the same as 2x plus 1, 2x plus 1, and then we have x minus 1, which is the same as x minus 1 is square, and then we have 2x plus 1. All right, so in here we have we have 3 real solutions, but 2 of them are the same. Okay, so therefore the roots for px equals 0 are so it's going to be x equal 1 twice if you want. Okay, 1 and 1 if you want, and then negative half. Okay, so we have 1, 2, 3 real solutions for this equation, and what happened is that 2 of them are the same. Okay, but still we have 3. Okay, so that is the answer for question 8. I'm going to do question 9, and then I'll have a break. Okay, question 9. Question 9, find an expression for C if x squared plus px plus q is exactly divisible by 2x plus c. Okay, so in there they say the word divisible, exactly divisible, meaning that 2x plus c is a factor of that polynomial. Okay, so we're going to say let p of x equal to that polynomial x squared plus bx plus q. Right. Okay, and then we have to find an expression for c. Okay, so this is the polynomial. This polynomial is exactly divisible by 2x plus c. All right, this is important. Okay, very, very important. Okay, as I say before, because this polynomial is exactly divisible by this, that means that 2x plus c is a factor of the polynomial. Okay, so we're going to say 2x plus c is exactly divisible. No, we're going to say p of x solution. P of x is exactly divisible by 2x plus c. So therefore 2x, so we're going to say then 2x plus c is a factor of p of x. Okay, consequences of that from the factor theorem is this. Therefore p at, now it's going to be careful because we have to make that equal to 0 in our head, okay, and make x the subject. Okay, so I said it again. Okay, so that when we say that is divisible by x minus 2, and then we say that p of 2 is equal to 0. Okay, what we are doing in our head, we made that equal to 0, and then the answer is equal to 2. Okay, and then we put that number in there. All right. Okay, so similarly, if you make that equal to 0, okay, let's do it in here. So it's 2x plus c equals 0. Then we have to make x the subject. So we're going to have that x is equal to negative c on 2. Okay, and then we substitute that in here. So therefore, minus c over 2 is equal to 0 because this is a factor of the polynomial. All right. So keep in mind that what we're actually doing when we substitute a number in here, that we make, okay, we make that equal to 0 and find the answer for x, and that is the number that we put in here. All right. Okay. So this is what is happening. Okay. So this polynomial is exactly divisible by 2x plus c. So therefore, p of negative c on 2 is equal to 0. Okay, and we're going to substitute that in here, make that equal to 0, and find the answer for c. Okay, so then we have minus c on 2 square plus p multiplied by minus c on 2, and then plus q equal 0. Okay, so that is what we have. And then from here, we are going to obtain a quadratic equation for c, and then we're going to solve that equation. All right, so this is c squared on 4, and this is minus pc on 2, and then plus q equals 0. And then what we're going to do, we're going to multiply everything by 4, so that will give you c squared minus 2pc, and then plus 4q equals 0. Okay, and then we have a quadratic equation on C. And then what I have to say, so we're looking for two numbers that when you times them together equal 4. And then when you add them together equal -2. Okay, and we can see that those numbers are, well, do we have any? If not, then we're going to have to use the quadratic formula. Unfortunately, yeah, we don't have any two numbers that when you times them together equal 4, but when you add them equal -2. Okay, so we're going to have to use the quadratic formula. Therefore, we're going to say C is equal to, so in here we're going to have -2p, so it's going to be 2p, and then plus or minus a square root of 2p squared, so that will give you 4p squared, and then minus 4 times 1 times 4q, and all that divided by 2. Okay, so C is going to be equal to 2p plus or minus a square root of, now we're going to simplify this a little bit, that will give you 4p squared minus 16q, and then on 2, and then from here we can take the common factor 4, and when you take it out become 2, so it's going to be 2, and this become p squared minus 4q, and all divided by 2. Okay, so that is what they want. Okay, just to find an expression for C, so then this polynomial is exactly divisible by 2x plus C. Okay, all right, so we're going to have a break now, and then we'll continue with the rest of the question. Okay.